So we are recording right now, and like I said, we will have a quiz on those type 1, type 2 reactions.
Good morning, USA.
That's a definite thing. You have your homework lined out. We're going to put the sheet that has the homework on it, just so I can put it in front of the camera as well, that we will remember. Type 1s and type 2s. You're going to bring that to me, not tomorrow the 13th, but the 17th, the next time I see you, which is that Tuesday. Because there's no school Monday. So, let's talk about some naming, some acids, naming and writing formulas for acids. Ladies. So the first thing we got to do is we got to determine what is an acid. An acid is going to have is always going to be a compound with one or more hydrogens that are attached to some kind of negative ion. We're going to see hydrogen attached to nonmetals like chlorine, fluorine, sulfur, phosphorus, nitrogen. And when we see hydrogen and that negative charge, we're going to think acid. My hydrogen ions must always balance out whatever negative charge is on the negative ion. Just like ionic compounds. I'm still dealing with charges. So one thing we're going to see is those polyatomic ions are also going to come back as well. We'll see things like HCl, which we're going to see in a second. We're going to see H2SO4 or H3PO4 or PO3, H3PO3. We have different naming systems for each one that we do. Our naming system for our acids are going to be based on whatever the negative side of the acid is. And we'll see some examples and we'll walk through a couple of them together. Now you may see a question that comes up with this. It goes, what element is always present in all acids? Hydrogen. When I'm trying to determine if I'm looking at a formula and I'm not sure if I'm looking at an acid or ionic compound, I will look to wherever the first element is in the formula. If it is a metal, I'm looking at ionic compound. If I see hydrogen, I'm looking at an acid.
So, would polar molecules be acids? No.
Bipolar, so polar can be positive or negative. So we're only looking for negative ions. So like ammonium is the only polyatomic ion that we were to memorize that had a positive charge to it. We would not see H and NH4 because both of those would have a positive charge to them. They're repelling from each other. But if I had cyanide, then that with hydrogen, that would be an acid. If I saw nitrite with a hydrogen, that would be an acid. And there's different ways that we name them. And we're going to talk about that in a second. First atom. If my first atom is a metal, I'm looking at an ionic compound. If my first atom in my formula is a hydrogen, I'm looking at an acid. An easy way to help tell them apart. If I'm looking at a covalent compound, what do you think the first atom is going to be in my formula?
Non-metal?
Mm-hmm.
Non-metal?
Yeah, non-metal. other than hydrogen. So if I have to sit down and I have to figure out what I'm looking at, I can always tell what of the three categories I'm going to use. If it starts off with a metal, I'm looking only at an ionic compound. If it starts off with a hydrogen, I'm looking at an acid. If it starts off with a non-metal other than hydrogen, it's a covalent compound. Today we're focusing on acids. When we hang out next time after the quiz, we will do covalent. So let's put this to practice and also take a look at our first naming scheme. So we break up our acids into two groups. There's acids with or without oxygen. Without oxygen are our non-oxy acids, and they are the easiest ones to name because they are always usually binary. There's only one thing attached to the hydrogen. So here I see hydrogen and chlorine.
Hydrochloric acid.
You're getting ahead of me, yeah. If I break down the ions, my hydrogen has to be positive here because my chlorine is definitely negative. When naming my acid, I do not care that hydrogen's present. Hydrogen's present in every acid that we're going to talk about. What I'm going to do is I'm going to cross out the IDE of my chloride and drop that here in between hydro and ic. So hydrochloric acid. Every acid without oxygen is going to be written hydro, the cut up name, ic acid. Hydrofluoric acid, hydrobromic acid, hydroioic acid, hydronitric acid, and so on and so on. Let's do a couple other ones together. HBr. Now, you may see a lot of you say AQ beside it. This just stands for aqueous. You don't need to worry about that. This means it's in water. If I was to break hydrogen bromide into its two bits, what would be the charges? H plus, Br minus 1. So I'm going to pull the bromide over. I cut off the IDE. And I leave hydrobromic acid. Whew. What's up? Yeah, that's the skeleton. That's the rule. That's the skeleton. This hydro blank ic acid is the skeleton for every, helps if I push it up, every acid without oxygen. That is our rule. We're going to see 3 naming rules for acids. This is our first one. I'll leave that for a second. I guess 30 seconds. I'm going to move on. All right. Flip to the next one. Now I have 3 I'd like for you to try by yourself. Now I understand there may not be a lot of room here on the side for you to write your acid name, but like before, I want you to break up the formula into the 2 different charges. The name is whatever's going to be, whatever the negative ion is. The acid name is going to be the hydroblankic acid. And I'm going to give you 5 minutes to work on those 3. There we go. I know eventually we'll start. They are cute. No, the 2 just means that there's 2 minus 2. So look at color here in the same column of oxygen. All these have a minus 2 ion. So my hydrogen sulfate is left negative. I'll give you a hint for beryllium. You're cutting off the IUF. You haven't seen that one before. No, not because we're taking.
We have put on this stuff eventually.
Do a test on it.
What?
Yeah. Because after today, we only have one more thing to talk about. Yeah, just make sure you're a little closer.
Mister,
But yeah, you're on the right path.
can I use the bathroom after that?
So. One second. Dennis Chastain. Dennis. Alright. So it's hydrobromic acid.
Like the name. The name of the
So either way. Yeah. So the thing is, I'm still chopping off that end, right? So like, doesn't matter what it is. The thing is that when I have bromide, I still chop it off at the ID. With bromine, I still chop it off at the ID. I'm still abbreviating that. All right, ladies and gentlemen, since time is up, let's go ahead and take a look at those three. All right, so my formula, if I break it down, I have hydrogen for each one. My TE, if I'm looking at my periodic table, ow.
Wait, that's a Wait, are you okay?
I'm all right. I minus 1, F minus 1. The name for TE is tellurium, iodine, fluorine. In either case, I'm cutting off the end of it, right? So for tellurium, I cut off the IUM. And for the acid name, it's hydro, Telluric, telluric acid.
Hydrotelluric acid.
When I have
Hydroionic acid.
iodine, I cut off the INE. Guys, hydro, iodic acid. For HF, I cut off the INE or IDE. Hydrofluoric acid. Always hydro, what's left of my name, ic acid. You always cut off the end. So it's the same thing like you did for the ion. So like with oxygen, you didn't cut off just the 3 last words, you cut off the 4 last letters for oxide. Now luckily you never see hydroxylic acid because that's just H2O. But if I saw, let's pick another one I haven't looked at. Nitrogen. Nitrogen, I cut off the last 3 and left it as nitride, right? Is that what we got for nitrogen? Nitride? We've seen this before, yes?
Yes.
So if that was an acid, so H3N, it would be hydronitric acid. I'm still cutting at the same place. if I'm thinking about it in ionic terms, the nitride, cut that off. Nitrogen, I cut off the last four letters. Always going to end in IC. Hydro, whatever's left of the word, ic acid. That's always going to be true for our acids without oxygens. Let's talk about our acids with oxygens.
8.
We are going to focus mostly on polyatomic ions here.
So this is what? Like oxygen acid as oxygen?
Yeah, so these are all my oxygen ones, right? So that means, so my polyatomic ions, my sulfates, my sulfites, my phosphates, my phosphites, my chlorates, my chlorites. Trying to think of the other ones. My carbonates. 1, 2.
So it won't
My
say,
nitrates, my nitrites.
so it won't say hydro.
No.
Okay.
So I have to make a difference between my 8s and my ites. If my polyatomic ion ends with 8, I will remove the 8 and just leave ic. So HNO3, my ions, H plus, polyatomic ion is nitrate. I cut off the ATE, and the acid's name is nitric acid.
I ate something icy or icky.
It's important for us to know our polyatomic ions. Because I'm dealing with an 8, the naming scheme is different. If I'm dealing with an ite, the naming scheme is different. Oh my goodness.
Wait, so you don't like the hydro?
So remember, the hydrogen never gets wrapped up in the name because every acid has a hydrogen. It would be redundant if we went hydrogen nitric acid. And if I said hydronitric acid, I'm saying H3N. If I'm saying hydronitric acid. Much like our ionic compounds, where the name was just the metal and the polyatomic ion, I'm only going to write the polyatomic ion's name for the acid. I'm going to cut off a portion of it, either the 8 or the ite. And when it's 8, I will add an ic acid. Let's do a couple together real quick. What is the polyatomic ion that I have here? Carbonate. So my anion, is carbonate. Right? We all agree with this, yes? Now, to get the name, I have to cut off the 8 and add ic acid, making it carbonic acid. So, let's do another quick one real fast. HNO3. Oh, we already did this one. I'm done. I already did that one.
Come.
Wait.
Let's skip on that one because I have a couple extra ones that are later down the road. All right. Let's talk about when they end with ites.
Oh.
If it ends with ite, I want to remove the ite and add an OUS to it. So my example here is hydrogen with nitrite. I'm going to cross off the ITE and replace it with nitrous acid. So that's where I need to memorize those eights and my ites. If it's 8, it's ic acid. If it's ite, it's us acid. That's the big difference between the two. All right. So, let's do an example together. So we're gonna do a couple. We're gonna do a couple at the end. So I'm looking at my ions here. I'm gonna have hydrogen for sure. What polyatomic ion am I looking at right here?
Chloride.
Chloride. So if I'm going to name this, what am I going to do?
Chlorous acid.
Cut off the ITE. Chlorous acid. That's where it comes in, knowing those polyatomic ions. The quiz that you're going to take on Tuesday,
It's gonna be good.
it's not going to be acids. It's going to be type 1 ionic compounds and the type 2 ionic compounds. So, type 1 was the packet that we did. Type 2 was the transition metals. That's what the quiz is on. I'm under the assumption that not only have you guys been studying your polyatomic ions, but when I see you Tuesday, you will know their formulas, their names, and their charges. It's important for us to remember that though we have ites and eights, the only difference between the ites and the eights is the number of oxygens. The charges stay the same. They do not change. Even when I go from hypochlorite all the way to perchlorate, the charge never changes. The only thing that changes is my number of oxygens. Hmm?
What Jasmine 2.5?
It's next is Jen. Then it could be you.
Did you put your name for a second?
For a second there, I don't know what happened. I had a brain. Got hit with the brain fog. I know. It's terrible. I apologize.
Oh my God.
I'm gonna give you 5 minutes. I want you to skip. I want you to try number 1. Listen. So I'm sorry I got cut off a little bit. H3PO4. I will tell you this: is that there's this little. I forgot to add. There's scratch 1. Don't do 1.
No.
Don't do it right now.
Okay.
Because we're going to see there's a specific rule for our phosphate. The name is going to follow the same rules, but there's one other thing that we have to add. Because, of course, in chemistry, we always get hit with exceptions. I want you to do the other 2.
Okay.
I'll give you 3.5 minutes to do those. What's up? No, I don't do Saturday morning seminar. I stay after Monday through Thursday. I don't have the time to do Saturday as well.
Wait, the 2?
What?
The last 2?
Yeah, I want you to focus on the last 2.
Baby. Get it together, baby. That's what I'm saying.
Yeah. All right. Let's look at them together fast. So, I want to target the bottom 2 first. So I got cut off HCl O3 If I break it down to the ions, I see I'm working with chlorate. Therefore, I cut off the 8, replace that with an ic acid. Now, when I see ClO by itself, hypochlorite. I cut off the ite, hypochlorous acid. Now, the reason why I said don't do the phosphate one is because there's an important exception. Because if I did it by the rules, I should come out with phosphic acid. And that just sounds wrong. Because it is. Because we're going to add something to it. The correct writing is going to be phosphoric acid. Yes. What's up? Because the name of my polyatomic ion is hypochloric acid. Hypochlorite. I'm only worried about losing the ITE. Everything else stayed the same because chlorite is ClO2. That would be chlorous acid. There are a couple of exceptions. I want to put those out to you. And these are the exceptions. So when I'm dealing with phosphorus, phosphate, or phosphite, the rule stays the same, but I'm going to add an OR in between my word. Sulfate, sulfite fall in the same situation. We're going to add a UR. That's why I want you to hit the pause real fast on the phosphoric acid. Because we had not mentioned that when it comes to, when it comes to phosphate, we have to add that OR before the IC. I'm pretty sure, have you guys ever heard of phosphoric acid before?
Yeah.
Once you're done, sorry, I'm going to flip it back over. Once you're done, I want you to try to name my 6 acids. I want you to write the formulas for the 6 acids at the bottom of your page. Look at your patterns. Hydros, uses, X. It'll tell you where you need to go. If there's no hydro, that means it's a polyatomic ion. All right, 2 minutes. I need to freeze one up here. All right, I'm going to freeze one up here. What I want you to do is I want you to try those 6. I'm going to write the formulas out. I'm going to give you 5 minutes to work on them. And we'll do a quick rundown of them just for you to check your answers. Remember, my clock is like 4 minutes fast.
This number?
No. Yeah, the first 20 are
Right now, just those first couple. One, we just did acid, so we tested one instead of those. And then, the mix it out here, we get back up to the other contact next time. So now let's pause on the bottom line.
Oh my god, I remember that was such a trend. It was really just a trend. Did you see?
Yes.
I remember that was so hello. Oh wait, it's when you're stupid. Oh my god.
Back to your rules. Don't put the charges next to the item. I want you to actually make the formula. I want the actual formula. So if I'm looking at the first one, I don't want to see n plus h plus 1, NO2 minus 1. I want to see h, NO2. Is that good? Yep, great.
Amazing.
Sir, is the
That's what you're up. So, the chart, you have these charges. No, just pick, just number. So on the first page, I'll talk about it in a quick second. I'll remind you guys. All right, so here are your acids.
So don't put the
I wanted just a formula. I did not need the ions. You had to go to the end with it. Yes, hydrogen has a +1, but when I was looking at sulfuric acid, the charge on my sulfate is a -2. Therefore, I need 2 hydrogens to cancel that charge out.
Why is it so furry? It's so furry.
You were in the bathroom. You were in the bathroom. She was in the bathroom when you explained that.
Yeah. Oh, that's because there are some. Quick second. Some important exceptions because. Yeah, it's just that we're adding an OR to it.
Phosphate.
Because it'd be phosphoric acid, and that just does not sound correct. So they add the 4 to kind of help break up the syllables in the word.
Okay.
So same thing with sulfuric, they put a UR in front of it. But if you're following that pattern, I'm not going to break your case if you didn't get it exactly.
Sugar and acid.
Yes. All right. So you might want to put out your planner, or you might want to make some notes on your piece of paper. The first 20. So if you have your piece of paper out, you should put like a star or something, or put homework beside it. If you end up doing the whole thing, I mean, more power to you. I'm not going to stop
You
you.
give them extra credit.
Only the first 2 groups because you're taking the quiz on those next time. If you want extra credit, I want you to look at the acids. Where are my acids at? Name the following compounds. These are acids. We haven't done type 3 yet, so it's not fair for me to ask you to name your covalent compounds. Everything's atoms.
I know, but like
They're all that matter.
bro, these people, yeah, you're not gonna eat They look so bad.
We should go. You go like you should try like 5 weeks once and like do it. And then like. Well, some of